Let's dive into a quant interview question from Akuna Capital. This is classic probability puzzle with a twist. Imagine there are 5 babies in a room, 2 boys and 3 girls. Then, a 6th baby is brought in. But we don't know if this baby is a boy or a girl. Now, if we pick one baby at random, and it turns out to be a boy, what is the probability that the baby who was just added is a boy? In this lesson, we'll break down the reasoning step by step using clear explanations and a bit of probability theory. We start by clarifying the scenario. In the room, there are 2 boys and 3 girls, making 5 babies. One more baby is added, but we don't know their sex. There are 2 possible cases. Either the added baby is a boy, which we'll call event B, or the added baby is a girl. In total, after the new baby joins, we have 6 babies in the room. Our goal is to figure out, given that we randomly picked a boy, what is the probability that the added baby is a boy? The heart of this problem is conditional probability. This is where we want to know the likelihood of one event given that another event has already occurred. In mathematical terms, we write this as P of a given B. Specifically in our case, we are trying to find the probability that the added baby is a boy, given that the randomly chosen baby was a boy. Symbolically, we'll write this as probability that the added baby is a boy, given that we picked a boy. We'll solve this problem using Bayes' theorem, which is a fundamental rule in probability. Bayes' theorem helps us update our beliefs based on new information. It's usually written as probability of a given B equals the probability of B given a times the probability of A divided by the probability of B. Here A is the event that the added baby is a boy, and B is the event that we chose a boy at random. We'll use this relationship to solve the puzzle step by step. Let's define our events more clearly. Let event A represent that the added baby is a boy. Event B is the observation that we picked a boy at random. Since nothing is said about the likelihood of the added baby being a boy or a girl, we will assume both are equally likely, each with probability 1/2. So, probability of A is 0.5, and probability of not A, meaning the added baby is a girl, is also 0.5. Now, let's compute each piece of Bayes' theorem. Probability of B given means probability of choosing a baby boy, given that added baby is a boy. If the added baby was a boy, we have 3 boys and 3 girls. So the probability of picking a boy is 3 out of 6. Probability of A means probability that added baby is a boy. Since no extra information is given regarding this, we assume that it's 50% change of the added baby being a boy or a girl. Now, we have to calculate the probability of B, for which we use the law of total probability. First, if event A is true, then there are 3 boys and 3 girls in the room. So the probability of picking a boy at random is 3 out of 6, or 0.5. If A is not true, meaning the added baby is a girl, then there are only 2 boys and 4 girls, and the probability of picking a boy becomes 2 out of 6, or about 0.333. Next, we need the probability of our evidence, PAC, B, which is the probability that a randomly chosen baby is a boy, regardless of whether the new baby is a boy or a girl. We use the law of total probability for this. PB equals the probability of choosing a boy given A times the probability of A plus the probability of choosing a boy given not A times the probability of not A plugging in. We have PB equals 3/6 times 1/2 plus 2/6 times 1/2. Let's actually compute those numbers. 3/6 times 1/2 is 1.5 over 6. 2/6 times 1/2 is 1 over 6. Adding those together, we get 2.5 over 6, which can also be written as 5/12, or approximately 0.417. This is the overall probability that, in this whole setup, a randomly chosen baby is a boy. Now we use Bayes' theorem. Substitute the values we've calculated. The numerator is the probability that the added baby is a boy, times the chance that if so, you choose a boy at random. That's 0.5 times 0.5, which is 0.25. The denominator is the probability we just calculated, 2.5 over 6, or approximately 0.417. So, P a given, B equals 0.25 divided by 0.417. Doing the division, 0.25 divided by 0.417 is approximately 0.6. That means, given that you picked a boy, there's a 60% chance that the baby who was added was a boy. This is our final answer. Thank you for following along with this probability puzzle. If you enjoyed this clear, step-by-step explanation, make sure to subscribe to the channel for more engaging math, statistics, and quantitative reasoning videos. Don't forget to visit datalooper.com, where you'll find even more resources and educational content to help you master these kinds of problems. See you next time.